Let's start with a joke. A piece of ice fell in love with a Bunsen burner. "Bunsen, my flame, I melt whenever I see you," said the ice. The Bunsen burner replied, "It's just a phase you're going through." My presentation on why ice is slippery. By When Book This Out. I will begin with the science behind ice being slippery. The first topic is water. Water is the marvelous source of life on Earth. It is also known as dihydrogen oxide, or H2O. It is a molecule that forms one of the strongest weak bonds between itself, hydrogen bonds. Water appears in 3 states of form: gas, liquid, and solid. Ice is special because compared to other solids, it is less dense than the liquid it's formed. Ice is slippery because of a thin layer of water resting on top of the ice, and because water is a low viscosity liquid. The molecules move freely due to there being no permanent intermolecular bonds, and the transient bonds are weak. Therefore, the molecules slip into any crack or hole they can find and keep searching for them. This creates a shifting surface beneath one's own feet. Although it is generally agreed that the cause of ice's slipperiness is the thin layer of water at the top. However, the cause of that water is much disputed. Let's continue with the prevailing theories for the cause of ice's slipperiness. Pressure. The first theory is that pressure causes the ice to melt because the melting point lowers with increased pressure. However, it will not lower further than -22 degrees Celsius. This means that the ice that is cooler than -22 degrees Celsius should not be slippery, but it is. The next theory is that friction causes the ice to melt. Friction is the product of 2 surfaces rubbing against each other, creating heat. An object would pass by, melting the top layer of the ice, and then the ice would refreeze. The issue with this theory is that the layer of water is present even before it has ever been touched. The final official theory is that the top layer is always liquid because there is nothing above to hold the molecules down. Therefore, they are constantly shifting. The most likely cause is actually a combination of all 3. Personally, I think there may be some contribution from the fact that the top layer is the warmest because all the other layers refreeze each other, and on the top there is constant friction due to the air moving. Next, a little bit of history. In 1859, Michael Faraday was the first to propose that a thin film of water existed over ice, even at temperatures well below freezing. 100 years later, the scientists began to study the phenomena again. These are the sites I used. To finish off this video, remember, when ice is made, it is made slippery side up.